All right, in this video, we're just going to cover a couple more complicated problems that we didn't have time to cover in the main videos. Again, these are optional videos with bonus examples for your mathematical enjoyment. So we're going to start with problem number 90. For the following exercises, evaluate sine of 11 pi over 3, cosine of negative 5 pi over 6. So that's going to be sine, I already forgot. Sine of 11 pi over 3 times the cosine of negative 5 pi over 6. And again, you could just type this into a calculator and get an approximate answer. But if you want an exact answer, it's a little bit more involved. So let's look at both of these separately. Okay, let's do this one in red and this one in blue. So if you look over here, what is 11 pi over 3? You can convert this to degrees, or let's work in radians. 11 pi over 3 is almost 12 pi over 3, right? 11 pi over 3 is 12 pi over 3 minus 1 pi over 3. What's 12 pi over 3? That simplifies to 4 pi. That's 720 degrees. This is a big angle. This angle means 360 degrees. This is 2 pi. Another 2 pi. And then another pi over 3. This is our angle. This is the red angle. It has a reference angle of just pi over 3 radians. Okay, so in terms of trig, this is the same as pi over 3. So we have a triangle. Specifically, this red triangle is going to be pi over 3 here, pi over 6 up here. This is a special triangle. Short side is s. The hypotenuse is 2 times s. And the long side is the square root of 3 times s. We can just think of s equaling 1 if we want. It's in the first quadrant, so everything's positive. So the sine of 11 pi over 3 is just the sine of pi over 3. It's actually just root 3 over 2. So this is going to be square root of 3 over 2 times whatever that blue thing is. Well, let's find out what the blue thing is. Let's draw another picture. Negative 5 pi over 6. Well, that's negative pi. It's almost negative pi, right? 6 pi over 6 would be pi. But then it's pi over 6 lacking of that. That's 180 degrees in the downward direction. And then we go back pi over 6. Pi over 6 is 30 degrees. It's going to look something like this. Our reference angle is pi over 6. I said I was going to do it in blue, so let's do it in blue. We have this triangle now. This is the triangle that we care about, this blue triangle. Well, if it's pi over 6, it's 30 degrees. We have, again, another one of these special triangles. Short side is some s. Hypotenuse is twice that. Long side, square root of 3 times that short side. And again, we can think of these as negatives if you want. It's in the third quadrant. The x-coordinate, right? We're going left. We're going down. Left and down correspond to negatives. So the cosine of this is the adjacent divided by the hypotenuse, or negative root 3 over 2. Well, let's just simplify this. So it's getting a little cluttered. My apologies. The square root of 3 times the negative square root of 3 is negative square root of 9. 2 times 2 is 4. Oh, this simplifies real nicely. This is negative 3/4. All that work. And something nice and easy. Let's use a calculator. Let's see if the calculator confirms it. The sine of 11 pi over 3 radians times the cosine of negative 5 pi over 6. 0.75 is 3/4. All right, we could have used a calculator. We didn't have to do it by hand. Usually you have to do things by hand if you want an exact answer. But I fooled you guys. Actually, I didn't know the answer either. We were just figuring it out together. The next one we're going to do is problem number 100. So, use this scenario. A child enters a carousel that takes 1 minute. Takes 1 minute to revolve all the way around. I'm not even done yet, but I'm going to write things down. Okay. So they're on this little carousel. It takes 1 minute to go all the way around. 1 minute per revolution. Let's say they're starting right here and they're going this way, because that's usually how we think for angles. They start on the very right and it goes counterclockwise. So, nope. All right. Look at what it says next, right? The child enters at the point 0, 1. All right. So they enter up here. I've been foiled. Next, they're going to say, I'm going to lose my direction next, huh? This is where they enter at the point 0, 1. Due north, and it revolves counterclockwise. All right, well, at least it still revolves the same direction. So the question is, in number 100, what are the coordinates of the child after 45 seconds? After 45 seconds. Well, after 60 seconds, it goes all the way around, right? 60 seconds, it's back where it started. That's a full revolution. And again, it's going to be the 0.01. Well, if it's 60 seconds for a full revolution, right? That means 15 seconds would be a quarter. 45 would be 3/4. So what's a quarter revolution? This is where it would be. After 15, then after 30, after 45. And that's the logic that we're going to use here. All right, so that would be the point. -1, 0. And 30 seconds would be down here. 45 would be right there. We can just jump to the answer, I think. 45 seconds is going to be 3/4 the way around, or this point right here of 1, 0. And that's our answer. So let's maybe, you know how I wrote this point at the very beginning of this example? Maybe I was just jumping to the answer subconsciously. And that's how you do these problems. You got 1 or 2 of these, I think I assigned you. All right, good luck, and let me know if you have questions.